example of exponential decay, one way to solve the problem is to realize that we could be working with a function that looks like this, where we're using a base of e, and a sub 0 represents the initial mass of the radioactive substance. And as you can see here, I somehow come up with this value for a sub 0, which is 17.63, and that the k in the formula is minus the natural log of 2 divided by 11. So it has that decimal representation. F of 11, that's the half-life, 11 years, is 8.81, which looks like it's half of the starting value. And if you look at this table here, here's the starting value, and every 11 years, it goes down by half. Here's the fact that after 20 days, there's 5 milligrams of the substance left, but the rest of these show an additional 11 years. And every 11 years, the amount of that substance is going down by half of what it used to be. So that's what we mean by half-life. Question is, how did I come up with these expressions here? And we'll go to the next board and I'll give you an idea. By the way, this is an example of exponential decay. This is a graph of that function where a sub 0 is this expression right here, and k is this expression right here. So here's the key. There's the form we want to use. We're told that when t is 11, that this amount is half of a sub 0. So if we divide both sides by a sub 0, a sub t divided by a sub 0, I could have put 11 here, is equal to 1/2. So we have 1/2 equals e to the 11k. That's the 11 years or 11 days right there. How do we solve this for k? We take the natural log of both sides. We apply the property of logarithms that if I have the log of a power, I can move the exponent down front. And the natural log of e is 1. So this thing just becomes a 1. I've got 11k equals the log of 1/2. So k equals the log of 1/2 divided by 11. Or if you want to say the log of 1/2 is the log of 1 minus the natural log of 2, ln of 2 divided by 11, but the ln of 1 is 0. So that's how I got that value for k. So at that point, we've got a of t equals a sub 0 e to this thing right here raised to the t power. Now we're given another piece of information that says when t is 20, a of t equals 5. That allows us to set up this equation and solve for a sub 0. So a sub 0 equals 5 divided by this mess right here, where this is the 20 years, that's the t, and this is the k, minus ln of 2 divided by 11. And up here, I've kind of changed the way a sub 0 looks. I could have left it this way, but just so you can see what I did here, I moved this exponent, negative 20/11, onto 2 as an exponent, and e to the log of anything is the anything. And then if I want to move this power to the numerator, I can change the exponent to have the opposite sign. So there's your formula right there. Obviously, you're going to have to use a calculator to evaluate it at different times t. And we're told that we're asked in part B, when does a of t equal 0.5? So I'm going to put a 0.5 here and realize that if I divide both sides by a sub 0, I'm just going to write a sub 0 here, I'll get that equals e to the minus ln of 2 divided by 11 t. You'll have to take the natural log of both sides. move this down front, and then you solve for t by dividing by this value k. It gets pretty messy, but I'm going to leave it there. Hope you have some idea how to proceed. You definitely need some kind of calculator to get these answers.